Keyboard layout.
A keyboard layout is any specific mechanical, visual, or functional arrangement of the keys, legends, or key meaning associations of a computer, typewriter, or other typographic keyboard. Most computer keyboards are designed to send scancodes to the operating system, rather than directly sending characters. From there, the series of scancodes is converted into a character stream by keyboard layout software. This allows a physical keyboard to be dynamically mapped to any number of layouts without switching hardware components, merely by changing the software that interprets the keystrokes. It is usually possible for an advanced user to change keyboard operation, and third-party software is available to modify or extend keyboard functionality.
Key types.
A computer keyboard comprises alphanumeric or character keys for typing, modifier keys for altering the functions of other keys, navigation keys for moving the text cursor on the screen, function keys and system command keys, such as ESC and BREAK, for special actions, and often a numeric keypad to facilitate calculations. There is some variation between different keyboard models in the mechanical layout, that is, how many keys there are and how they are positioned on the keyboard. However, differences between national layouts are mostly due to different selections and placements of symbols on the character keys.
Character keys.
The core section of a keyboard comprises character keys, which can be used to type letters and other characters. Typically, there are 3 rows of keys for typing letters and punctuation, an upper row for typing digits and special symbols, and the space bar on the bottom row. The positioning of the character keys is similar to the keyboard of a typewriter.
Modifier keys.
Besides the character keys, a keyboard incorporates special keys that do nothing by themselves but modify the functions of other keys. For example, the Shift key can be used to alter the output of character keys, whereas the Ctrl, Control, and Alt, alternate, keys trigger special operations when used in concert with other keys. Typically, a modifier key is held down while another key is struck. To facilitate this, modifier keys usually come in pairs, one functionally identical key for each hand, so holding a modifier key with one hand leaves the other hand free to strike another key. An alphanumeric key labeled with only a single letter, usually the capital form, can generally be struck to type either a lowercase or capital letter, the latter requiring the simultaneous holding of the Shift key. The Shift key is also used to type the upper of 2 symbols engraved on a given key, the lower being typed without using the modifier key. The English alphanumeric keyboard has a dedicated key for each of the letters AZ, along with punctuation and other symbols. In many other languages there are special letters, often with diacritics, or symbols, which also need to be available on the keyboard. To make room for additional symbols, keyboards often have what is effectively a secondary Shift key, labeled Alt-GR, which typically takes the place of the right-hand Alt key. It can be used to type an extra symbol beyond the 2 otherwise available with an alphanumeric key, and using it simultaneously with the Shift key may give access to even a 4th symbol. On the visual layout, these 3rd level and 4th level symbols may appear on the right half of the key top, or they may be unmarked. Instead of the Alt and Alt-GR keys, Apple keyboards have CMD, Command, and Option keys. The Option key is used much like the Alt-GR, and the CMD key like the Ctrl on IBM PCs, to access menu options and shortcuts. The main use of the actual Ctrl key on Macs is to produce a secondary mouse click, and to provide support for programs running in X11, a Unix environment included with OS X as an install option, or MIS Windows. There is also a FN key on modern Mac keyboards, which is used for switching between use of the F1, F2, etc. keys either as function keys or for other functions like media control, accessing dashboard widgets, controlling the volume, or handling expose. FN key can be also found on many IBM PC laptops, where it serves a similar purpose. Many Unix workstations, and also home computers like the Amiga, Keyboards place the Ctrl key to the left of the letter A, and the caps lock key in the bottom left. This layout is often preferred by programmers as it makes the Ctrl key easier to reach. This position of the Ctrl key is also used on the EXA laptop, which does not have a caps lock. The Unix keyboard layout also differs in the placement of the ESC key, which is to the left of one. Some early keyboards experimented with using large numbers of modifier keys. The most extreme example of such a keyboard, the so-called Space Cadet keyboard found on MIT Lisp machines, had no fewer than 7 modifier keys, 4 control keys, CTRL, meter, hyper, and super, along with 3 shift keys, shift, top, and front. This allowed the user to type over 8,000 possible characters by playing suitable chords with many modifier keys pressed simultaneously.
Dead keys.
A dead key is a special kind of a modifier key that, instead of being held while another key is struck, is pressed and released before the other key. The dead key does not generate a character by itself, but it modifies the character generated by the key struck immediately after, typically making it possible to type a letter with a specific diacritic. For example, on some keyboard layouts, the grave accent key is a dead key. In this case, striking and then A results in A with grave accent, whereas followed by E results in E with grave accent. A grave accent in isolated form can be typed by striking and then space bar. A key may function as a dead key by default, or sometimes a normal key can temporarily be altered to function as a dead key by simultaneously holding down the secondary shift key, Alt-GR or Option. In some systems, there is no indication to the user that a dead key has been struck, so the key appears dead, but in some text entry systems the diacritical mark is displayed along with an indication that the system is waiting for another keystroke, either the base character to be marked, an additional diacritical mark, or space bar to produce the diacritical mark in isolation. Compared with the secondary shift modifier key, the dead key approach may be a little more complicated, but it allows more additional letters. Using the secondary shift, you may only type one or, if you use it simultaneously with the normal shift key, 2 additional letters with each key, whereas using a dead key, a specific diacritic can be attached to a number of different base letters.
Compose key.
A compose key can be characterized as a generic dead key that may in some systems be available instead of or in addition to the more specific dead keys. It allows access to a wide range of predefined extra characters by interpreting a whole sequence of keystrokes following it. For example, striking compose followed by apostrophe, and then A results in A with acute accent, compose followed by A and then E results in E ligature, and compose followed by O and then C results in C, circled C, copyright symbol. The compose key is supported by the X Window system, used by most Unix-like operating systems, including most Linux distributions. Some keyboards have a key labeled compose, but any key can be configured to serve this function. For example, the otherwise redundant right-hand Win key may, when available, be used for this purpose.
History.
Keyboard layouts have evolved over time. The earliest mechanical keyboards were used in musical instruments to play particular notes. With the advent of printing telegraph, a keyboard was needed to select characters. Some of the earliest printing telegraph machines used a layout similar to a piano keyboard. In countries using the Latin script, the center, alphanumeric portion of the modern keyboard is most often based on the Qwerty designed by Christopher Scholes, who laid out the keys in such a way that common 2-letter combinations were placed on opposite sides of the keyboard so that his mechanical keyboard would not jam, and laid out the keys in rows offset horizontally from each other by 3/8, 3/16, and 3/8 inches to provide room for the levers. Although it has been demonstrated that the Qwerty layout is not the most efficient layout for typing, it has become such a standard that people will not change to a more efficient alphanumeric layout. Scholes chose the size of the keys to be on 3/4 inch, 0.75 inch, centers, about 19 mm, versus musical piano keys which are 23.5 mm or about 0.93 inches wide. 0.75 inches has turned out to be optimum for fast key entry by the average size hand, and keyboards with this key size are called full-sized keyboards. The standard 101/100 key PC keyboard layout was invented by Mark Tiddens of Keytronic Corporation in 1982. IBM adopted the layout on its PC-AT in 1984, after previously using an 84-key keyboard which did not have separate cursor and numeric keypads. Most modern keyboards basically conform to the layout specifications contained in Parts 1, 2, and 5 of the International Standard Series ISO/IEC 9995. These specifications were first defined by the user group at AFNOR in 1984 working under the direction of Alain Saloumiac. Based on this work, a well-known ergonomic expert wrote a report which was adopted at the ISO Berlin meeting in 1985 and became the reference for keyboard layouts. The 104/105 key PC keyboard was born when two Win keys and a menu key were added on the bottom row, originally for the Microsoft Windows operating system. Newer keyboards may incorporate even further additions, such as Internet access, World Wide Web navigation, keys and multimedia, access to media players, buttons.
Mechanical, visual and functional layouts.
Today, most keyboards use one of three different mechanical layouts, usually referred to as simply ISO, ISO/IEC 9995-2, ANSI, ANSI and SIDS 154-1988, and JIS, JISX 6002-1980, referring roughly to the organizations issuing the relevant worldwide, United States, and Japanese standards, respectively. In fact, the mechanical layouts referred such as ISO and ANSI comply to the primary recommendations in the named standards, while each of these standards in fact also allows the other way. Keyboard layout in this sense may refer either to this broad categorization or to finer distinctions within these categories. For example, as of May 2008 Apple Incorporated produces ISO, ANSI, and JIS desktop keyboards, each in both extended and compact forms. The extended keyboards have 110, 109, and 112 keys, ISO, ANSI, and JIS, respectively, and the compact models have 79, 78, and 80.
Mechanical and visual layouts.
Mechanical layouts only address tangible differences among keyboards. When a key is pressed, the keyboard does not send a message such as the A key is depressed but rather the leftmost main key of the home row is depressed. Technically, each key has an internal reference number, raw key codes, and these numbers are what is sent to the computer when a key is pressed or released. The keyboard and the computer each have no information about what is marked on that key, and it could equally well be the letter A or the digit 9. The user of the computer is requested to identify the visual layout of the keyboard when installing the operating system. Visual layouts vary by language, country, and user preference, and the same mechanical layout can be produced with a number of different visual layouts. For example, the ISO keyboard layout is used throughout Europe, but typical French, German, and UK variants of mechanically identical keyboards appear different because they bear different legends on their keys. Even blank keyboards, with no legends, are sometimes used to learn typing skills or by user preference.
Functional layout.
The functional layout of the keyboard refers to the mapping between the physical keys, such as the A key, and software events, such as the letter A appearing on the screen. Usually the functional layout is set to match the visual layout of the keyboard being used, so that pressing a key will produce the expected result, corresponding to the legends on the keyboard. However, most operating systems have software that allow the user to easily switch between functional layouts, such as the language bar in Microsoft Windows. For example, a user with a Swedish keyboard who wishes to type more easily in German may switch to a functional layout intended for German, without regard to key markings, just as a Dvorak touch typist may choose a Dvorak layout regardless of the visual layout of the keyboard used.
Customized functional layouts.
Functional layouts can be redefined or customized within the operating system, by reconfiguring operating system keyboard driver, or with the use of a separate software application. Transliteration is one example of that, whereby letters in other language get matched to visible Latin letters on the keyboard by the way they sound. Thus, touch typist can type various foreign languages with visible English language keyboard only. Mixed hardware to software keyboard extensions exist to overcome above discrepancies between functional and visual layouts. A keyboard overlay is a plastic or paper masks that can be placed over the empty space between the keys, providing the user with a functional use of various keys. Alternatively, a user applies keyboard stickers with an extra imprinted language alphabet and adds another keyboard layout via language support options in the operating system. The visual layout of any keyboard can also be changed by simply replacing its keys or attaching labels to them, such as to change an English language keyboard from the common Qwerty to the Dvorak layout, although for touch typists, the placement of the tactile bumps on the home keys is of more practical importance than that of the visual markings. In the past, complex software that mapped many non-standard functions to the keys, such as a flight simulator, would be shipped with a keyboard overlay, a large sheet of paper with pre-cut holes matching the key layout of a particular model of computer. When placed over the keyboard, the overlay provided a quick visual reference as to what each key's new function was, without blocking the keys or permanently modifying their appearance. The overlay was often made from good quality laminated paper and was designed to fold up and fit in the game's packaging when not in use.
National variants.
The US IBM PC keyboard has 104 keys, while the PC keyboards for most other countries have 105 keys. In an operating system configured for a non-English language, the keys are placed differently. For example, keyboards designed for typing in Spanish have some characters shifted, to release space for NN. Similarly, those for French or Portuguese may have a special key for the character CC. Keyboards designed for Japanese may have special keys to switch between Japanese and Latin scripts, and the character Y equals, Japanese yen or Chinese yuan currency symbol, instead of backslash, which may be replaced by the former in some typefaces and kodachis. Using a keyboard for alternative languages leads to a conflict, the image on the key does not correspond to the character. In such cases, each new language may require an additional label on the key, because the standard keyboard layouts do not even share similar characters of different languages. The United States keyboard layout is used as default in the currently most popular operating systems, MS Windows, Apple Mac OS X and Linux. Most operating systems allow switching between functional keyboard layouts, using a key combination involving register keys that are not used for normal operations, for example Microsoft Reserve Alt+Shift or Ctrl+Shift register control keys for sequential layout switching. Those keys were inherited from old DOS keyboard drivers. There are keyboards with two parallel sets of characters labeled on the keys, representing alternate alphabets or scripts. It is also possible to add a second set of characters to a keyboard with keyboard stickers manufactured by third parties.
Qwerty-based layouts for Latin script.
Although there are a large number of different keyboard layouts used for different languages written in Latin script, most of these layouts are quite similar. They can be divided into three main families according to where the Q, A, Z, M, and Y keys are placed on the keyboard. These are usually named after the first 6 letters. While the core of the keyboard, the alphabetic section, remains fairly constant, and the numbers from 1 to 9 are almost invariably on the top row, keyboards differ vastly in the placement of punctuation characters, which punctuation characters are included, whether numbers are accessible directly or in a shift state, the presence and placement of dead keys and letters with diacritics. The actual mechanical keyboard is of the basic ISO, ANSI, or JIS type. functioning is entirely determined by operating system or other software. It is customary for keyboards to be used with a particular software keyboard mapping to be engraved appropriately. For example, when the Shift and numeric 2 keys are pressed simultaneously on a US keyboard, AT is generated, and the key is engraved appropriately. On a UK keyboard, this key combination generates the double quote character, and UK keyboards are so engraved. In the keyboard charts listed below, the primary letters or characters available with each alphanumeric key are often shown in black in the left half of the key, whereas characters accessed using the Alt-G key appear in blue in the right half of the corresponding key. Symbols representing dead keys usually appear in red.
Qwerty.
By far the most widespread layout in use, and the only one that is not confined to a particular geographical area. Some varieties have keys like Enter and Caps Lock not translated to the language of the keyboard in question. In other varieties such keys have been translated, such as Block Mayas for Caps Lock, in the Spanish keyboards. On Macintosh computers these keys are usually just represented by symbols without the word Enter, Shift, Command, Option Alt, or Control.
Qwerty.
The Qwerty layout is fairly widely used in Germany, Austria, Switzerland and much of Central Europe. The main difference between it and Qwerty is that Y and Z are swapped, and some special characters such as brackets are replaced by diacritical characters.
AZERTY.
The AZERTY layout is used in France, Belgium and some African countries. It differs from the Qwerty layout thus. A and Q are swapped, Z and W are swapped, M is moved to the right of L, where :semicolon is on a US keyboard, the digits 0 to 9 are on the same keys, but to be typed the Shift key must be pressed. The unshifted positions are used for accented characters, Caps Lock is replaced by Shift Lock, thus affecting non-letter keys as well. However, there is an ongoing evolution towards a Caps Lock key instead of a Shift Lock.
AZERTY Lithuanian.
Lithuanian keyboards use a layout known as AZERTY, where A appears in place of Q above A, Z in place of W above S, with Q and W being available either on the far right-hand side or by use of the Alt-G key. Depending on the software used, the Lithuanian symbols can also be positioned in the place of digits, 1 for A, 2 for C, 3 for E, 4 for E, 5 for I, 6 for S, 7 for U, 8 for U and equals for Z.
QZERTY.
The QZERTY layout is used mostly, if not exclusively, in Italy, where it was the traditional typewriter layout. Computer keyboards usually have Qwerty, although non-alphanumeric characters vary. Z and W are swapped, M is moved from the right of N to the right of L, as in AZERTY, number keys are shifted. Apple supported QZERTY layout in its early Italian keyboards, and currently iPod Touch also has it available.
Non-Qwerty keyboards for Latin scripts.
There are also keyboard layouts that do not resemble Qwerty very closely, if at all. These are designed to reduce finger movement and are claimed by some proponents to offer higher typing speed along with ergonomic benefits.
Dvorak.
The Dvorak Simplified Keyboard (DSK) layout, also known as the American Simplified Keyboard (ASK) layout, is the best-known alternative to Qwerty. It was named after its inventor, August Dvorak. There are also numerous adaptations for languages other than English, and single-handed variants. Dvorak's original layout had the numerals rearranged, but the present-day layout has them in numerical order. The Dvorak Simplified Keyboard has numerous properties designed to increase typing speed, decrease errors, and increase comfort. A research has found a modest 4% average advantage to the end user in typing speed. The most prominent property involves concentrating the most used English letters in the home row where the fingers rest, thus having 70% of typing done in the home row, compared to 32% in Qwerty. The Dvorak simplified keyboard is available out of the box on most operating systems, making switching through software very easy. Hardwired Dvorak keyboards are also available, though only from specialized hardware companies.
Qwerty.
The Qwerty keyboard layout is another alternative to the standard Qwerty layout, offering a more incremental change for users already accustomed to the standard layout. It builds upon the Qwerty layout as a base, changing the positions of 17 keys while retaining the Qwerty positions of most non-alphabetic characters and many popular keyboard shortcuts, supposedly making it easier to learn than Dvorak for people who already type in Qwerty. It shares several design sensibilities with Dvorak, such as minimizing finger path distance and making heavy use of the home row. An additional defining feature of the Qwerty layout is the lack of a caps lock key. An additional backspace key occupies the position typically occupied by caps lock on modern keyboards. The Qwerty layout is supported out of the box in NetBSD, FreeBSD, DragonflyBSD, Haiku, Chrome and Linux, Mac OS X and iOS, hardware US keyboards, and Android, as well as in the Xorg implementation of the X Windows system. A program to install the layout is available for Microsoft Windows, as well as a portable auto-hotkey implementation.
JCUKEN Latin.
The JCUKEN layout was used in the USSR for all computers, both domestically produced and imported, such as Japan-made MSX-compatible systems, due to its phonetic compatibility with Russian Itsarken layout, see below. The layout has the advantage of having punctuation marks on Latin and Cyrillic layouts mapped on the same keys.
Neo.
The Neo layout is an optimized German keyboard layout developed in 2004 by the Neo Users Group, supporting nearly all Latin-based alphabets, including the International Phonetic Alphabet, the Vietnamese language and some African languages. The positions of the letters are not only optimized for German letter frequency, but also for typical groups of 2 or 3 letters. English is considered a major target as well. The design tries to enforce the alternating usage of both hands to increase typing speed. It is based on ideas from de Ergo and other ergonomic layouts. The high-frequency keys are placed in the home row. The current layout Neo 2.0, available since 2010, has unique features not present in other layouts, making it suited for many target groups such as programmers, mathematicians, scientists or latex authors. Neo is grouped in different layers, each designed for a special purpose. Most special characters inherit the meaning of the lower layers, for example the character is one layer above the, or the Greek A is above the A character. Neo uses a total of 6 layers with the following general use.
Plover.
Plover is an open-source program that turns a coding keyboard into a stenographic typewriter. There are numerous advantages to using these systems, but they are fundamentally different from ordinary typing. Words are input by pressing on several keys and releasing simultaneously. The keys are not required to be pressed down in any order, and only a subset of the keys are used on the keyboard. Experienced typists can use this input method to capture speech in real time, which can take at least 180 WPM for literary works and 225 WPM for casual speech, but reaching this level usually takes years of intense study with dropout rates of 85% or more. However, getting up to a speed that equals or exceeds 120 WPM, the speed of a very fast regular typist, can be reasonably expected within 6 months.
BEPO.
The BEPO layout is an optimized French keyboard layout developed by the BEPO community, supporting all Latin-based alphabets of the European Union, Greek and Esperanto. It is also designed to ease programming. It is based on ideas from the Dvorak and other ergonomic layouts. Typing with it is usually easier due to the high-frequency keys being in the home row.
Turkish F keyboard.
The Turkish language uses the Turkish Latin alphabet, and a dedicated keyboard layout was designed in 1955 by Ihsan Sıtkı. During its design, letter frequencies in the Turkish language were investigated with the aid of Turkish Language Association. These statistics were then combined with studies on bone and muscle anatomy of the fingers to design the Turkish F keyboard. The keyboard provides a balanced distribution of typing effort between the hands, 49% for the left hand and 51% for the right. With this scientific preparation, Turkey has broken 14 world records in typewriting championships between 1957 and 1995. In 2009, Reese Pertez, and in 2011, Hakan Kurt from Turkey came in first in the text production event of the 47th, Beijing, and 48th, Paris, Intersteno Congresses respectively. Despite the greater efficiency of the Turkish F keyboard, however, the modified Qwerty keyboard, Q keyboard, is the one that is used on most computers in Turkey. The reason for the popularity of Qwerty in Turkey is that they were overwhelmingly imported since the beginning of 1990s.
Corded keyboards and mobile devices.
The multi-touch screens of mobile devices allow implementation of virtual on-screen corded keyboards. Buttons are fewer, so they can be made larger. Symbols on the keys can be changed dynamically depending on what other keys are pressed, thus eliminating the need to memorize combos for characters and functions before use. For example, in the corded GKOS keyboard, which has been adapted for the Google Android, Apple iPhone, Miss Windows Phone and Intel Make Maton platforms, thumbs are used for chording by pressing one or two keys at the same time. In the layout, the keys are divided in two separate pads which are located towards the sides of the screen, and the text appears in the middle. The most frequent letters have dedicated keys and do not require chording. Some other layouts have also been designed specifically for use with mobile devices. The Vitally layout, which is optimized for use with a stylus to place the most commonly used letters closest to the center and minimize the distance traveled when entering words. A similar concept was followed to research and develop the Messages keyboard layout for fast text entry with stylus or finger. The Atomic layout, designed for stylus use, was developed by IBM using the Metropolis algorithm to mathematically minimize the movement necessary to spell words in English. The Atomic keyboard layout is an alternative to Qwerty and ShapeWriter's writing pad software. Corded keyboards in general, such as the stenotype and bulotype, allow letters and words to be entered using combinations of keys in a single stroke. Users of stenotype machines can often reach rates as high as 300 words per minute, and these systems are commonly used for real-time transcription by court reporters and in live closed captioning systems. As of 2010, there is one implementation of stenographic software for use with ordinary gaming anti-aliasing keyboards, called Plover. It's intended for the home user, as gaming keyboards are quite inexpensive.
Other original layouts and layout design software.
Several other alternative keyboard layouts have been designed either for use with specialist commercial keyboards, for example Maltron and Plum, or by hobbyists, for example Asset, Erencito, Minimac, Norman, QWPR, and Workman. However, none of them are in widespread use, and many of them are merely proofs of concept. Principles commonly used in their design include maximizing use of the home row, minimizing finger movement, maximizing hand alternation or inward rolls, where successive letters are typed moving towards the center of the keyboard, minimizing changes from Qwerty to ease the learning curve, and so on. Maltron also has a single-handed keyboard layout. Programs such as the Microsoft Keyboard Layout Creator, Basic Editor, free for use on Miss Windows, Cyrillic, Advanced Editor, free for use on the Apple Mac OS, KBD Edit, Commercial Editor, for Windows, and Keyman Developer, Commercial Editor for Windows, or for sites on the web as virtual keyboards, make it easy to create custom keyboard layouts for regular keyboards. Users may satisfy their own typing patterns or specific needs by creating new ones from scratch, like the IPA or Pan-Iberian layouts, or modify existing ones, for example, the Latin American Extended or Gaelic layouts. Microsoft's Keyboard Layout Creator can even construct complex key sequence using dead keys and Alt-G key. Some high-end keyboards such as the Kinesis Advantage contoured keyboard allow users total flexibility to reprogram keyboard mappings at the hardware level. A few companies offer ABC, alphabetical, layout keyboards.
Keyboard layouts for non-Latin alphabetic scripts.
Some keyboard layouts for non-Latin alphabetic scripts, most notably the Greek layout, are based on the Qwerty layout, in that glyphs are assigned as far as possible to keys that bear similar sounding or appearing glyphs in Qwerty. This saves learning time for those familiar with Qwerty. This is not a general rule, and many non-Latin keyboard layouts have been invented from scratch. All non-Latin computer keyboard layouts can also input Latin letters as well as the script of the language, for example, when typing in URLs or names. This may be done through a special key on the keyboard devoted to this task, or through some special combination of keys, or through software programs that do not interact with the keyboard much.
Arabic.
This layout was developed by Microsoft from the classic Arabic typewriter layout and is used by IBM PCs. For Apple keyboards there is a different layout.
Armenian.
The Armenian keyboard is similar to the Greek in that in most, but not all, cases, a given Armenian letter is at the same location as the corresponding Latin letter on the Qwerty keyboard. The illustrated keyboard layout can be enabled on Linux with typmap and variant Eastern.
Brahic scripts.
Media related to Brahic keyboard layouts at Wikimedia Commons.
Bengali.
There are many different systems developed to type Bangla language characters using a typewriter or a computer keyboard and mobile device. There were efforts taken to standardize the input system for Bangla in Bangladesh, Jatio layout, but still no input method has still been effectively adopted widely.
InScript.
InScript is the standard keyboard for 12 Indian scripts including Devanagari, Bengali, Gujarati, Gurmukhi, Kannada, Malayalam, Oriya, Tamil and Telugu etc. Most Indian scripts are derived from Brahmi, therefore their alphabetic order is identical. On the basis of this property, the InScript keyboard layout scheme was prepared. So a person who knows InScript typing in one language can type in other scripts using dictation even without knowledge of that script. An InScript keyboard is inbuilt in most modern operating systems including Windows, Linux and Mac OS. It is also available in some mobile phones.
Khmer.
Khmer uses its own layout roughly matched to the equivalent of its Qwerty counterpart. For example, the letter L is typed on the same space as the letter L on the English-based Qwerty. Since most Khmer consonants have two forms, the shift key is used to switch between the first and second forms. The glyph below the lettering is used to type in subscripts when they occur in a cluster. Since spaces are used in Khmer to separate sentences and not words, the space option is activated when pressed with the shift key only. Otherwise it has no effect.
Sinhalese.
The Sinhala keyboard layout is based on the Ajesakara typewriter for Sinhala script.
Thai.
The less frequently used characters are accessed by the shift key. Despite their wide usage in Thai, Arabic numbers are not present on the main section of the keyboard. Instead they are accessed via the numeric keypad. The backtick key is blank, because this key is typically used to switch between input languages. Beside the Kedmani layout also the Patakot layout is used.
Tibetan. Tibetan China.
The Chinese national standard on Tibetan keyboard layout standardizes a layout for the Tibetan language in China. The first version of Microsoft Windows to support the Tibetan keyboard layout is MIS Windows Vista. The layout has been available in Linux since September 2007.
Tibetan International.
The first version of Microsoft Windows to support the Tibetan keyboard layout is MIS Windows Vista. The layout has been available in Linux since September 2007. Mac OS X introduced Tibetan Unicode support with OS X version 10.5 and later, now with 3 different keyboard layouts available: Tibetan Y, Tibetan Qwerty and Tibetan Notani.
Dzongkha Bhutan.
The Bhutanese standard for a Dzongkha keyboard layout standardizes the layout for typing Dzongkha, and other languages using the Tibetan script, in Bhutan. This standard layout was formulated by the Dzongkha Development Commission and Department of Information Technology in Bhutan. The Dzongkha keyboard layout is very easy to learn as the key sequence essentially follows the order of letters in the Dzongkha and Tibetan alphabet. The layout has been available in Linux since 2004.
Cyrillic.
Media related to Cyrillic keyboard layouts at Wikimedia Commons.
Bulgarian.
The current official Bulgarian keyboard layout for both typewriters and computer keyboards is described in BDS, Bulgarian State National Standard, 5237-1978. It superseded the old standard, BDS 5237-1968, on January 1, 1978. Like the Dvorak keyboard, it has been designed to optimize typing speed and efficiency, placing the most common letters in the Bulgarian language, O, N, T and A, under the strongest fingers. In addition to the standard 30 letters of the Bulgarian alphabet, the layout includes the non-Bulgarian Cyrillic symbols E and Y and the Roman numerals I and B. The X is supposed to be represented by the Cyrillic capital KH, which is acceptable in typewriters but problematic in computers. There is also a second, informal layout in widespread use, the so-called phonetic layout, in which Cyrillic letters are mapped to the Qwerty keys for Latin letters that sound, or look the same, with several exceptions: ear is mapped to Q, ZH is mapped to V, etc. See the layout and compare it to the standard Qwerty layout. This layout is available as an alternative to the BDS-1 in some operating systems, including Microsoft Windows, Apple Mac OS X and Ubuntu Linux. Normally, the layouts are set up so that the user can switch between Latin and Cyrillic script by pressing Shift+Alt, and between BDS and phonetic by pressing Shift+Ctrl. In 2006, Professor Demeter Skorda from the Faculty of Mathematics and Informatics of Sofia University and Imita Dobrev from the Bulgarian Academy of Sciences proposed a new standard, PRBDS 5237-2006, including a revised version of the old BDS layout and a standardization of the informal phonetic layout. After some controversy and a public discussion in 2008, the proposal was not accepted, although it had been already used in several places. The Bulgarian phonetic layout in MIS Windows Vista is based on it.
Moldovan.
The Moldovan Cyrillic keyboard layout is based on a mixture of Russian phonetic and Serbian keyboard layout while adding a unique letter ZH to the layout in place of the letter DZH on the Serbian Cyrillic layout. This is the EZHEAT layout. The letter I is mapped the same as on the standard Russian layout, while letter I is mapped where J is in Serbian layout. Also, letters and Y are remapped. This unofficial keyboard layout can be found here.
Russian.
The most common keyboard layout in modern Russia is the so-called Windows layout. It is the default Russian layout used in the MIS Windows operating system. This layout allows using keyboards of the same physical design as in many other countries but has some usability issues for Russian language users. Because of a design decision, the comma and full stop symbols are on the same key in this layout, and users need to hold Shift every time they enter a comma, although the comma is much more frequent in the language. There are some other Russian keyboard layouts in use, in particular, the traditional Russian typewriter layout. Punctuation symbols are placed on numerical keys, one needs to press Shift to enter numbers, and the Russian DOS layout, similar to the Russian typewriter layout with common punctuation symbols on numerical keys, but numbers are entered without Shift. The Russian typewriter layout can be found on many Russian typewriters produced before the 1990s, and it is the default Russian keyboard layout in the Open Solaris operating system. Keyboards in Russia always have Cyrillic letters on the keytops as well as Latin letters. Usually Cyrillic and Latin letters are labeled with different colors. The Russian phonetic keyboard layout, also called homophonic or transliterated, is widely used outside Russia, where normally there are no Russian letters drawn on keyboard buttons. This layout is made for typists who are more familiar with other layouts, like the common English Qwerty keyboard, and follows the Greek and Armenian layouts in placing most letters at the corresponding Latin letter locations. It is famous among both native speakers and people who use, teach, or are learning Russian, and is recommended, along with the standard layout, by the linguists, translators, teachers and students of artsil.org. There are several different Russian phonetic layouts, for example yazhet, yazhut, yawert, yavert, and yashiat, yashat, also sometimes with a y/y, that is yazhurti, yazhuti, yawerti, iavati, etc. They are named after the first several letters that take over the Qwerty row on the Latin keyboard. They differ by where a few of the letters are placed. For example, some have Cyrillic B, which is pronounced B on the Latin W key, after the German transliteration of B, while others have it on the Latin V key. There are also variations within these variations. For example, the Mac OS X phonetic Russian layout is Yashiat but differs in placement of ZH and E. A virtual, on-screen, Russian keyboard allows entering Cyrillic directly in a browser without installing Russian drivers. Another virtual keyboard supports both traditional, MIS Windows and typewriter, and some phonetic keyboard layouts.
Serbian Cyrillic.
Apart from a set of characters common to most Cyrillic alphabets, the Serbian Cyrillic layout uses 6 additional special characters unique or nearly unique to the Serbian Cyrillic alphabet: LJ, NJ, TSH, DJ, DZH and J. Due to the bialphabetic nature of the language, actual physical keyboards with the Serbian Cyrillic layout printed on the keys are uncommon today. Typical keyboards sold in Serbian-speaking markets are marked with Serbian Latin characters and used with both the Latin, Qwerty, and Cyrillic layout configured in the software. What makes the two layouts this readily interchangeable is that the non-alphabetic keys are identical between them, and alphabetic keys always correspond directly to their counterparts, except the Latin letters Q, W, X, and Y that have no Cyrillic equivalents, and the Cyrillic letters LJ, NJ and DZH whose Latin counterparts are digraphs ALJ, NJ and DZ. This also makes the Serbian Cyrillic layout a rare example of a non-Latin layout based on Qwerty. The Macedonian DZE is on this keyboard despite not being used in Serbian Cyrillic. The G and G can be typed by striking the apostrophe key then striking the G or K key. There is also a dedicated Macedonian keyboard that is based on Qwerty, and uses all GR to type the G and TSHE. However, the capital forms are next to the small forms.
Ukrainian.
Ukrainian keyboards, based on a slight modification of Russian standard layout, often also have the Russian standard, Windows layout marked on them, making it easy to switch from one language to another. This keyboard layout had several problems, one of which was the omission of the letter G, which does not exist in Russian. The other long-standing problem was the omission of the apostrophe, which is used in Ukrainian almost as commonly as in English, though with a different value, but which also does not exist in Russian. Both of these problems were resolved with the improved Ukrainian keyboard layout for Windows available with Vista and subsequent Windows versions. There also exists an adapted keyboard for Westerners learning Ukrainian, mostly in the diaspora, which closely matches the Qwerty keyboard, so that the letters either have the same sound or same shape. For example, pressing the V on the Latin Qwerty produces the Cyrillic V, which makes roughly the same sound, and pressing the Qwerty W key gives the Cyrillic sh, based on the similar shape.
Georgian.
All keyboards in Georgia are fitted with both Latin and Georgian letters. As with the Armenian, Greek, and phonetic Russian layouts, most Georgian letters are on the same keys as their Latin equivalents.
Greek.
The usual Greek layout follows the US layout for letters related to Latin letters, abdhikamnopstis, abdikamnopshks, respectively, substitutes visually or phonetically similar letters, ph at f, g at g, and uses the remaining slots for the remaining Greek letters, ks at j, ps at c, o at v, th at u. Greek has 2 fewer letters than English, but has 2 accents which, because of their frequency, are placed on the home row at the UK semicolon position. They are dead keys. Word final sigma has its own position as well, substituting w, and semicolon, which is used as a question mark in Greek, and colon moved to the position of q.
Hebrew.
All keyboards in Israel are fitted with both Latin and Hebrew letters. Trilingual editions including either Arabic or Russian also exist.
Inuktitut.
Inuktitut has 2 similar, though not identical, commonly available keyboard layouts for Windows. Both contain a basic Latin layout in its base and shift states, with a few Latin characters in the Alt-GI shift states. The Canadian Aboriginal syllabics can be found in the caps lock and Alt-GI shift states in both layouts as well. The difference between the 2 layouts lies in the use of as an alternate to Alt-GI to create the dotted, long vowel syllables, and the mapping of the small plain consonants to the caps plus number keys in the Nakatort layout, while the Latin layout does not have access to the plain consonants, and can only access the long vowel syllables through the Alt-GI shift states.
Tifina. Tamazight Berber.
The Tamazight, Tifina, standards-compliant layout is optimized for a wide range of Tamazight, Berber, language variants, and includes support for Qwerty variants. As mapped, it installs as Tamazight F, and can be used both on the French locale and with Tamazight locales. Qwerty and Qwerty adaptations are available for the physical keyboards used by major Amaz, Berber, communities around the world. Non-standards compliant but convenient combined AZERTY Latin script layouts exist which also allow typing into finer script without switching layout. Tamazight, International, is optimized for French keyboard compatibility, with Tamazight, Berber, as an extension and limited to finer script access, that is by dead key. It installs as Tamazight, Agralin, or Francais Plus. Tamazight, International, Plus is optimized for Tamazight, Berber, but with close French compatibility and easy typing into finer script. It installs as Tamazight, Agralin, Plus, or Tamazight Loaf. A non-standards compliant but convenient combined AZERTY map to finer layout exists which also allows typing in Latin script without switching layout. Tifina, International, Plus. It installs as Tifina, Agralin, Plus, or Tamazight FL. All the above layouts were designed by the Universal Amaz Keyboard project and are available from there.
Morocco.
The Royal Institute of the Amaz Culture, IRCAM, developed a national standard Tifina layout for Tamazight, Berber, in Morocco. It is included in Linux and Windows 8, and is available from IRCAM for the Mac and older versions of Windows. A compatible, international version of this layout, called Tifina, International, exists for typing a wide range of Tamazight, Berber, language variants, and includes support for Qwerty variants. It was designed by the Universal Amaz Keyboard project and is available from there.
East Asian languages.
Chinese, Japanese and Korean require special input methods, often abbreviated to CJKIMEs, input method editors, due to the thousands of possible characters in these languages. Various methods have been invented to fit every possibility into a Qwerty keyboard, so East Asian keyboards are essentially the same as those in other countries. However, their input methods are considerably more complex, without one-to-one mappings between keys and characters. In general, the range of possibilities is first narrowed down, often by entering the desired character's pronunciation. Then, if there remains more than one possibility, the desired ideogram is selected either by typing the number before the character, or using a graphical menu to select it. The computer assists the typist by using heuristics to guess which character is most likely desired. Although this may seem painstaking, East Asian input methods are today sufficient in that, even for beginners, typing in these languages is only slightly slower than typing English. In Japanese, the Qwerty-based JIS keyboard layout is used, and the pronunciation of each character is entered using Hepburn romanization or Kunreishiki romanization. There are several kana-based typing methods. See also Japanese language and computers. Chinese has the most complex and varied input methods. Characters can either be entered by pronunciation, like Japanese and Hanja and Korean, or by structure. Most of the structural methods are very difficult to learn but extremely efficient for experienced typists, as there is no need to select characters from a menu. For detailed description, see Chinese input methods for computers. There exist a variety of other, slower methods in which a character may be entered. If the pronunciation of a character is not known, the selection can be narrowed down by giving its component shapes, radicals, and stroke count. Also, many input systems include a drawing pad permitting handwriting of a character using a mouse. Finally, if the computer does not have CJK software installed, it may be possible to enter a character directly through its encoding number, for example Unicode. In contrast to Chinese and Japanese, Korean is typed similarly to Western languages. There exist two major forms of keyboard layouts, Dubielsic, and Sabielsic. Dubielsic, which shares its symbol layout with the Qwerty keyboard, is much more commonly used. While Korean consonants and vowels, JMO, are grouped together into syllabic grids when written, the script is essentially alphabetical, and therefore typing in Korean is quite simple for those who understand the Korean alphabet Hangul. Each JMO is assigned to a single key. As the user types letters, the computer automatically groups them into syllabic characters. Given a sequence of JMO, there is only one unambiguous way letters can be validly grouped into syllables, so the computer groups them together as the user types.
Hangul for Korean.
Media related to Korean keyboard layouts at Wikimedia Commons.
Dubielsic.
Dubielsic. 2-set is by far the most common and the sole national standard of Hangul keyboard layout in use in South Korea since 1969. Pressing the Hanyang key once switches between Hangul as shown, and Qwerty. There is another key to the left of the space bar for Hanja input. If using a 104-key keyboard, the right Alt key will become the HN key, and the right CTRL key will become the Hanja key. Consonants occupy the left side of the layout, while vowels are on the right.
Sabielsic 390.
Sabielsic 390, Sabielsic 390. 3-set 390, was released in 1990. It is based on Dr. Kong Young-woo's earlier work. This layout is notable for its compatibility with the Qwerty layout. Almost all Qwerty symbols that are not alphanumeric are available in Hangul mode. Numbers are placed in 3 rows. Syllable initial consonants are on the right, shown green in the picture, and syllable final consonants and consonant clusters are on the left, shown red. Some consonant clusters are not printed on the keyboard. The user has to press multiple consonant keys to input some consonant clusters, unlike Sabielsic final. It is more ergonomic than the Dubielsic, but is not in wide use.
Sabielsic final.
Sabielsic final, Sabielsic Kuijing. 3-set final, is another Hangul keyboard layout in use in South Korea. It is the final Sabielsic layout designed Dr. Kong Young-woo, hence the name. Numbers are placed on 2 rows. Syllable initial consonants are on the right, and syllable final consonants and consonant clusters are on the left. Vowels are in the middle. All consonant clusters are available on the keyboard, unlike the Cyrillic 390 which does not include all of them. It is more ergonomic than the Typographic, but is not in wide use.
Cyrillic no shift.
Cyrillic no shift is a variant of Cyrillic which can be used without pressing the shift key. Its advantage is that people with disabilities who cannot press two keys at the same time will still be able to use it to type in Hangul.
Chinese.
Chinese keyboards are usually in US layout with without Chinese input method labels printed on keys. Without an input method handler activated, these keyboards would simply respond to Latin characters as physically labeled, provided that the US keyboard layout is selected correctly in the operating system. Most modern input methods allow input of both simplified and traditional characters, and will simply default to one or the other based on the locale setting.
Mainland China.
Keyboards used in the mainland China are standard or slightly modified English US, Qwerty, ones without extra labeling, while various IMEs are employed to input Chinese characters. The most common IMEs are Hanyu Pinyin based, representing the pronunciation of characters using Latin letters. However, keyboards with labels for alternative structural input methods such as Wabi method can also be found, although those are usually very old products and are extremely rare to this day.
Taiwan.
Computers in Taiwan often used Cyrillic, Butpomofo, style keyboards, US keyboards with Butpomofo labels, many also with Kanji method key labels, as Kanji is the standard method for speed typing in traditional Chinese. The Butpomofo style keyboards are in lexicographical order, top to bottom, left to right. The codes of three input methods are typically printed on the Chinese, traditional, keyboard, Cyrillic, upper right. Kanji, lower left. And Dairi, lower right.
Hong Kong.
In Hong Kong, both Chinese, Taiwan, and US keyboards are found. Japanese keyboards are occasionally found, and UK keyboards are rare. Other input methods include the Cantonese input method for the Cantonese language speakers. The romanization requires users to spell out the Cantonese sound of each character without tone marks, for example Hung and Kong, or Gong for Hong Kong/Xi and Gang, and to choose the characters from a list. The advantage of the Cantonese input method is that nearly all Cantonese speakers can input traditional Chinese characters on their very instinct. No particular training and practice is required at all. The advantage available to a Hanyu Pinyin user is that any keyboard with just an English layout, that is, without Bopomofo markings engraved, can deploy the Pinyin IME for bilingual, both Chinese and English on the same document, input. All those who have received formal education in mainland China can easily input with Hanyu Pinyin without any formal training. The drawback of Hanyu Pinyin to a Hong Kong native Cantonese speaker is that the alphabets are not pronounced exactly in the same way as the common English language syllables should be pronounced, because it is only the Latin letters in the keyboard that have been used by the Hanyu Pinyin method. Although Cantonese input method seems intuitive to Hong Kong people, it is an unpopular input method for various reasons. There are many characters that can have the same syllable in the spelling only, they sound the same but are written with different characters, that needed to be differentiated by different intonations for speech communication. Unless a user has also input a phonetic intonation or an accent numeral, that is, 1, 2, 3, or 4. To narrow down the list of possible combinations, he or she can have a substantial set of ambiguous Chinese characters of the same pronunciation to select. The selection process can slow down the input speed for those who have not input an accent numeral after each and every Cantonese spelling. There is no official standard for Cantonese romanization, and there are multiple romanization schemes, which leads to different Cantonese input method implementations adopts different romanizations. Moreover, Hong Kong students almost never learn any of the romanization schemes. Also, Microsoft Windows, which is the most popular operating system used in desktops, doesn't carry Cantonese input method, users would need to find a third-party input method software and install into Windows to use Cantonese input method, which may be cumbersome for system administrators who are responsible for office computers. For these reasons, Hong Kong computer users often have to resort to use those harder shape-based Chinese input methods, for example kanji. Or for those with formal Mandarin education, they may choose pinyin instead. A minority of users may even have to use a graphics tablet designed to recognize handwritten Chinese characters. Thorough training and practice are required to input correctly with Changji or Kanji, yet it is, by impression, the quickest Chinese input method. Many Cantonese speakers have taken Changji or Kanji input courses because of the fast typing speed availed by the input method. This method is the fastest because it has the capability to fetch the exact, unambiguous Chinese character which the user has in mind to input, pinpointing to only one character in most cases. This is also the reason why no provision for an input of phonetic accent is needed to complement this input method. The Changji or Kanji character feature is available on both Mac OS X and Windows. On Mac OS X, the use of the multi-touch pads of modern Macs makes it possible to write a glyph with a finger and the correct character is recognized by the computer. The clumsiest Chinese input method is the stroke input method, which is ideal for those who are not so proficient in spelling the Cantonese language in English alphabets nor Mandarin in pinyin. The method is widely installed in mobile phones with small screens because the method only requires 5 key taps for the 5,000 commonly used Chinese characters. It is also considered too tedious, requiring a user to type out all the strokes constituting a single Chinese character. Chinese characters sharing the same 3 to 5 beginning brush strokes are grouped to respond to users' tapping sequences. Thus, there yields a lengthy list of more than 40-some Chinese characters having these similar beginning strokes for the user to confirm which one of the listed characters should be the intended one to input. The character picking process is a must for the stroke input method users regardless of whether the traditional or simplified Chinese character set is to be used. To a native Hong Kong Cantonese speaker who can spell the Cantonese dialect fairly accurately in English alphabets and who types Chinese in ad hoc occasions only, Cantonese input method is, by far, the most convenient Chinese input method both for phone book searching and for word processing using laptops and smartphones.
Japanese.
Media related to Japanese keyboard layouts at Wikimedia Commons. The JIS standard layout includes Japanese kana in addition to a Qwerty style layout. For entering Japanese, the most common method is entering text phonetically, as romanized, transliterated, kana, which are then converted to kanji as appropriate by an input method editor. It is also possible to type kana directly, depending on the mode used. For example, to type Takahashi, a Japanese name, one could type either take as, I in romanized, Ramaji, input mode, or QTFD in kana input mode. Then the user can proceed to the conversion step to convert the inputs into the appropriate kanji. The extra keys in the bottom row, Mahin-kan, Hien-kan, and the hiragana katakana switch key, and the special keys in the leftmost column, the Hankaku-Zenkaku key at the upper left corner, and the ASU key at the caps lock position, control various aspects of the conversion process and select different modes of input. The Oye by Shifuto, thumb shift, layout is based on kana input, but uses 2 modifying keys in place of the space bar. When a key is pressed simultaneously with one of the keys, it yields another letter. Letters with the Dakuten diacritic are typed with the opposite side thumb shift. Letters with hand Dakuten are either typed while the conventional pinky-operated shift key is pressed, that is, each key corresponds to a maximum of 4 letters. Or, on the Nicola variation, on a key which does not have a Dakuten counterpart. For example, the H key in the Qwerty layout individually yields Ha, but with the A thumb shift key, yields Mi. Simultaneous input with L thumb shift yields Ba, which is the individually mapped letter with the aforementioned Dakuten. While the pinky-operated shift key is pressed, the same key yields Pa. This same letter must be typed with L thumb shift plus Y on the Nicola variant. For more details, see the section on East Asian languages above, and the articles Japanese language and computers, Japanese input methods, and language input keys.